All right, let's try and take a look at this monstrosity and see if we can make any sense of it. We're going to start the process the same way. Take all of the parallel resistors and convert them to an equivalent resistance, and then add all of those in series to find the total resistance, find the total current in the circuit, and then start breaking down those individual parallel parts. So I see here we have 10 ohms plus 12 ohms. They're in series, so we add them together. And we come to our first parallel part. 1 over 8 plus 1 over 16 plus 1 over 8 equals, and then 1 over that value gives you a resistance of 3.2. Plus 6. Do the same process here. 1 over 10 plus 1 over 18 equals, reciprocate, 6.4 or 6.43. That gives us total resistance of 37.6 ohms. Okay. Then, to find the total current, we're going to take our voltage, which is 60, and divide it by the resistance we just found, and that's going to give us our current of about 1.60 amps. Now that is the current that's going to flow throughout this whole series circuit. And so A1 and A2 will both be 1.6 amps. Now, let's work on these voltmeters. Remember, voltage is current times resistance. So, if we take the current of 1.6 times the resistor value of 10, we get a voltage here of 16 volts. Do the same process here. We're going to take 12 times 1.6 and get 19.2 volts. Now here we know that the equivalent resistance of this is 3.2. 3.2 times 1.6 is 5.12. 6 times 1.6 and finally this equivalent resistance was 6.43 times 1.6 gives us about 10.2 volts. If you take a look and add up these different voltages from around the circuit, you're going to find that it adds up pretty closely to this 60 volt source. Now we need to figure out the rest of these ammeter values. Now remember, current is voltage divided by resistance. We know the resistor values for each of these, and we know the voltage that goes through them. Now remember, in a parallel circuit, the voltage is the same across all of the components in that parallel part. So here we're going to take 5.12 divided by 8, and that's going to give us 0.64 amps. And we're going to do the same process. This is twice the resistor, so it will produce half of the voltage current. That's going to give us a 0.32. And the last one is the same resistance, and so it's going to give us the same current. Okay. And now we have these two. Again, 10.2 volts divided by a current of 1. Divided by a resistance of 10. That's going to give us 1.02. And here, the 18. 5.7. Here's the other thing to notice that you can double check. Just like we added up all of these voltages around the circuit, and they were very close to within some rounding 60 volts, the current that comes into a parallel part needs to equal the current that comes out. 1.6 is our current. If you take these two and add them together, you get 1.59. That's pretty close. You can do the same thing here, and these three currents will add up to this 1.6. So I hope that even though this problem looked ridiculously complicated and convoluted, that once you start breaking these problems down, they go a lot smoother for you. Thanks.